Greetings, everyone. Okay, so here's the AP Calculus AB free response question number 5 from 2018. Let's take a look. Please pause the video and go try the problem before actually watching me solve it. But it says, let f be the function defined by fx equals e to the x times cosine of x. Find the average rate of change of f on the interval from 0 less than or equal to x less than or equal to pi. Alright, so it's just a simple average rate of change problem. Now, just make sure you know that it's an average rate of change, not an average value. Remember, those are two different things, and they're related to each other, but we've got to make sure when we see the word average, we pay attention. Is it an average value or average rate of change? If it was average value, we'd want the average value integral, but here, an average rate of change is something we've been doing since pre-cal at the very least, and we're just going change in f over change in x here. So this is going to be f of pi minus f of 0 over pi minus 0. This is a non-calculator question, so you're going to leave this in exact form, so you don't have to worry about much simplifying. We're just going to plug in, pretty much leave things alone. So if I plug in pi, obviously we'll get e to the pi times cosine of pi. We should remember that cosine of pi is -1, so it'll be negative e to the pi. If I plug in 0, cosine of 0 is 1, and e to the 0 is also 1, so it'll be -1, and then we'll just have pi in the denominator. And we'll just leave it like that. So, moving on to part B. So, in part B, it says to find the slope of the line tangent to the graph of f at x equals 3 pi over 2. So, now we want to actually do some calculus here, because part A is not really doing calculus. Part A is really doing some pre-cal stuff. So to find the slope, we need to take the derivative, and we need to do the product rule here. So we'll take the derivative of the first factor, e to the x, times the second factor, cosine of x, plus the derivative of the second factor, which is going to be negative, come on, my screen, there we go. Had trouble technologically there. Derivative of cosine is negative sine times the, what's up with my pen right now, times the first factor, e to the x. And then from here, all we need to do is plug in 3 pi over 2, and remember a little bit of trig to do some simplifying. E to the 3 pi over 2 is going to remain e to the 3 pi over 2. Hopefully you remember that cosine of 3 pi over 2 is 0, because cosine being the x-coordinate of the point on the unit circle at 270-degree rotation, or 3 pi over 2 radians, the x-coordinate is 0. And then plus, or minus sine of 3 pi over 2. Hopefully you remember sine of 3 pi over 2 being that y-coordinate of the point I just talked about. That's going to be -1. And then we're going to have another e to the 3 pi over 2. Make that a little clearer. Wow, pen is giving me trouble today. And so, when we work this out, that works out to be just, and again, you don't have to simplify, but I'm going to, a slope of e to the 3 pi over 2. By the way, question A was only worth 1 point, and that wasn't really calculus much, so that's understandable. This is worth 2 points, 1 point for finding f prime, and 1 point for actually evaluating the slope. So there you go, there's B. Pretty straightforward. See problems like this on the AP, you should be happy because there are not a lot of difficult stuff yet. So we already got 3 out of the 9. It's a good start. Alright, going back to the question, for letter C, we need to find the absolute minimum of f on the interval from 0 to 2 pi inclusive, and we need to justify our answer. Since we're dealing with a closed interval here, we have a continuous function on a closed interval, so we know there's going to be a max and a min, although we're only looking for the min. We're going to use the closed interval method for this. And so let's get to the screen here. So we already found the derivative here, and actually I'm going to pause it and rewrite this. Actually, I'm going to cut and paste. I'll pause first though. Alright, so I'm back. So of course we want to set f prime of x equal to 0 to go ahead and start looking for critical numbers. And then if we do a little bit of algebra, we'll factor out the e to the x, and we'll be left with cosine of x minus sine of x. And then e to the x never equals 0, so we just need to figure out when cosine of x minus sine of x is equal to 0. Now, this goes back to your trig experience from before. We need cosine of x to be equal to sine of x. Now, if you know every trig function in the first quadrant is positive, so there'll be a point where sine and cosine are the same in the first quadrant. You should know that as pi over 4. And then in the second quadrant, they're opposite signs, and same in the fourth quadrant, they're opposite signs, so they're not going to be equal there. They are both negative in the third quadrant, and the third quadrant angle that has the reference angle pi over 4 will be 5 pi over 4, or just pi plus pi over 4. So we need to now test those values in the original function, and also we need to test the endpoints, and I'll do that when I'm going to pause and set up a new screen on the next page real quick. Alright, for organizational purposes, I've made a little table with the endpoints and the interior points, and then here's the function. If I plug in 0, we're going to get 1, because e to the 0 is 1, cosine of 0 is also 1. If I plug in 2 pi, cosine of 2 pi is 1, so I'm going to get e to the 2 pi. And then if I plug in pi over 4, well, cosine of pi over 4 is 1 over root 2, so I'll write that in here first. E to the pi over 4. You might be thinking, without a calculator, what am I going to do with that value? Luckily, they try to set it up so it works out pretty well. When you plug in 5 pi over 4 into the cosine function, as we said a little while ago, that's a third quadrant angle, and so cosine is negative in the third quadrant, and it has the same reference angle, pi over 4, so it's just going to be negative 1 over root 2, e to the 5 pi over 4. And now it's obvious which one is the minimum, the absolute minimum, because there's only one negative number on there. The rest are positive, so the negative has to be the absolute minimum. So write a sentence. I'm just going to, don't write the word sentence like I am. I'm being obnoxious, but write a sentence saying the absolute minimum is, and that way the AP examiners know exactly what you mean. Last but not least is part D. Let's go back to the question here. It says that G be a differentiable function such that G of pi over 2 equals 0. The graph of G prime, the derivative of G, is shown below. Find the value of this limit as x approaches pi over 2 of f of x over g of x, or state that it does not exist and justify your answers. Excuse me. All right, let's take a look. I'm missing a screen here. Alright, I thought I had the limit written down somewhere, but apparently I don't. So except the limit as x approaches pi over 2 of f of x over g of x. Well, f of x, let's go back to the screen here. F of x, if I look at f of pi over 2, cosine of pi over 2 is 0. So the numerator is going to go to 0 here. And g of pi over 2, they already told us that g of pi over 2 is also 0. That was given in part D. So this is a L'Hopital's rule problem. And I've told you that most of the time when you have a limit on the AP exam free response section, you're probably going to be using L'Hopital's rule. So this is no surprise that we need it here. So we get the limit as x approaches pi over 2. We're going to have f prime of x over g prime of x. And the graph of g prime was given. So now when we take a look at this, I'm sorry, I'm just debating whether I want to write this out anymore or not. We already said that the numerator here, this is going to be e to the x from an earlier problem, cosine of x times cosine of x minus sine of x. And then over g prime, and we have to go get the values from the table for g prime. So the numerator, when I plug in pi over 2, cosine is going to become 0, sine of pi over 2 is 1, so we're going to have negative 1. So our numerator is going to become negative e to the pi over 2. The denominator, well, I got to go look back at the graph and look at g prime of pi over 2. So now remember, this is the graph of g prime right here. So I'm not looking at slopes because they gave me the graph of g prime. So now I've just got to look at the output of g prime at pi over 2, and the output of g prime at pi over 2 is getting closer and closer to 2. And so make sure, yeah, just make sure my pen strokes didn't cover it. Yeah, that's getting closer to 2 right there. So that goes to 2, if I can find that screen. And that looks like a Z. Let me make it look more like a 2, close enough. And there it is. That's a 3-point question. So, we applied, that's a 3-point question. We apply L'Hopital's rule, and then we get the answer. Ooh, they wanted one more point here, which is something I overlooked, but I'm looking at the solutions here. And they give you 1 point to say that g is continuous at x equals pi over 2, and the limit equals 0. Now, we've already said the limit for g of x equals 0 up here when we did this part of that earlier argument. But we never mentioned that g is continuous at x equals pi over 2 in order for us to apply L'Hopital's rule. How do we know g is continuous? Well, they told us that g is differentiable, so we should probably mention back in here, and that's, you know, a little bit of my sloppiness, but let's go put that in here. So we can apply L'Hopital's rule. I would say, you know, since g is differentiable, g is continuous. Whoops. And so we could apply L'Hopital's rule here. So something I overlooked, but now you know. Go study.